and welcome everybody to this Spatial Data Science Conference. It really is a pleasure to be here, and it was actually quite surprising to see how many new people are for the conference, so I certainly hope you enjoy it. I like to say that this is a conference done by geo enthusiasts for geo enthusiast people. So I really invite you to connect with people on the conference. There's some great conversations going on here. I mean, we couldn't be, I think, in a better place to talk about the future of geospatial and GIS. So yeah, I hope really, get the most out of it. So pretty amazing place. Now, I also would like to start by thanking some of our sponsors. I think it also is a testament, on the importance that geospatial is taking in the larger picture of analytics. So when you see, like Snowflake, Google Cloud, Databricks, and AWS, those are some of the major, if not, that probably represents like 90% or more of everything analytics these days, right? And the fact that they're here, sponsoring and actually contributing is also a testament towards their investments that they're doing on geospatial. I think, there's also talks around how we are opening up our industry. And I really invite you to, there's gonna be talks from them, but also learn around their investment they're doing. They're adding a lot of geospatial capabilities on the products that will be of great value for you. There's, as Helen said, there's an area for sponsors out there, and I really invite you to look at them. Also, to our data sponsors, Dataplorer and Safegraph, and they have great data sets. I know that many of you need to, in our world, geospatial data, you always need third-party data to put in context your own data. So I highly invite you to go and visit, what they get to offer. Oh, actually, get this, nice. Oh, is this going? No. Just look at. Now, I will, very often, on the conference, I start, by talking about the climate change. And 2024 was not obviously an exception. In fact, it's been the warmest year so far in history, right? So I think, that gives us, obviously, what we all know, the urgency on the topic. And just I look at it, from this context, one thing that, impressed me over the last year is that Antarctica, for example, melted during winter time. I'm talking about during, when it's dark, when it's actually, there's no sun, and when the ice will be growing, it actually shrink, right? So it's a very big warning towards, what it's, how the climate is rapidly changing on our geography. But we also saw during last year, some great, things like discoveries of new species, obviously something that I like a lot. We're very close here to the Natural History Museum. They actually are responsible for discovering a lot of new species every year. Some of my favorites, for example, is the vegetarian piranha. It's the first one that we found. I really like that. But yeah, it also is again, a reference about how many things are still to be explored. Every year it's estimated that we discover around 18,000 new species, from snakes in the Himalayas, to frogs in, in the forest. There's still so much to be discovered. Always exciting that way. But it was also a year of flooding, and Spain saw quite a bit in Valencia. You're probably aware of it, but all around the world. Flooding kept going and going. Flooding maps are getting now updated all the time, and it's just expanding. Flooding is really defined in geography, so it was also a very big reminder around the geography. How is it changing on these things? But also on the positive side, the renewable energy, solar and wind, are finally overpassing fossil fuels in Europe. That was the year. This is the year that it happened. 56% of the production of energy in Europe was driven by solar and wind, right? And we're talking about an industry where I like it because, if you think about geo and GIS, for a long time, one of the biggest use cases was helping drilling oil, right? Going, and finding, where to find new fossil fuels. And now we are seeing the same, our technology being used, for finding, where to place solar plants, where to how to, and wind. For me, that's also very, very exciting. But you can see how geography is at the center a lot of these revolutions, right? It's a great, year for the advances. But at the same time, a few weeks back, I don't know if I'm sure you're familiar. Also, you saw it. We got a huge blackout in Spain and Portugal. In less than 5 seconds, the whole system went down. Talking about also the vulnerabilities. But the other story of it was the amazing recovery. Most of the, around 99% of the entire Spain and Portugal got electricity back in less than 12 hours. And that recovery at a kind of like continental scale is pretty amazing. And that's talking about, like how do you kind of like electrify every new transformer? It's a huge kind of like geospatial and graph problem to kind of restart an electric network like this, right? So for me, again, like it's a great testament about how geospatial is really fundamental in also in cases of emergencies like this. So what connects all of this, back again, is this need to connect, like space and time, and to need about it, like from climate change, how we do in electricity. Have you seen all these examples are just telling us how important it is our work in a way, and that's also why, honestly, why I'm so excited about working on geography and what you should too. But I think, like it is a testament of like how important it is that the work that we're doing and that the work that we are doing is accessible to everybody. In fact, like this is one of the main topics of my, not the main topic of my talk, is around how we can make, like geospatial accessible to everybody, right? So we see why it's very important, but unfortunately, still it's fair to say that, like it remains a need, it remains, like a silo on its own, and it's our responsibility to keep pushing so that, more people has access to it, can benefit from its insights, and, and that honestly, that we just see more geospatial being done because it's really just very important. So how we actually kind of work on this, I wanted to kind of like express it in two main topics that I think are really now very transformative and are a very great opportunity to make this happen. One is opening up geospatial data with the concept of these open table formats, how we can make our data just more widely accessible. And I'll talk about it in a minute. How we make it, more relevant with the rest of analytics, how we can make it, so that we don't have our own formats, but, like that we're part of a bigger community that is, that can benefit from it. And the second is how can we make, like our insights, how can we make our products, like our maps much more accessible so that people can get more value from them. And for that, obviously, AI is a very big advance that, we're gonna benefit a lot. And these two topics are heavily interconnected because if we don't make, our data widely more accessible, we're not gonna be able to benefit from the advances that are happening in AI. If we keep maintaining our own geospatial formats that only us can read and so on, forget about, like the advances that, like AI are bringing to analytics, right? And how it's making it more accessible. So for me, they go hand to hand. So I'm gonna start talking about open table formats, and then we'll go to geospatial reasoning. So first of all, what is open table formats? On the analytics industry, this is something that is right now very, very hot. And I wanted to bring it to our community. So those are formats like, if you haven't heard of things like Iceberg or Parquet. Those are like data formats that are used for handling very large data sets that, like in an interoperable way. And what has been traditionally the industry required that if you were betting for an analytics platform, let's say BigQuery, Snowflake, or Databricks, very often you had to prepare your data to run on that platform. Well, with open table formats, the whole idea is that you can store your data in one of those open table formats like Iceberg, and then you will be able to use it with any engine on top of it. You don't have to move the data. So you can imagine how important this is in the industry because it provides a lot of like flexibility for users to choose which engine they use and how they use it. So you get a lot of interoperability, you get like faster queries because of the way that it uses the cloud, and it's vendor neutral and future proof. So this revolution is very, very quickly happening now on analytics. And I want to kind of bring it to our industry too, to geospatial, right? So you were here in 2022, actually we announced something called GeoParquet. It was our first try to bring geospatial data to this wider community of formats, right? It's kind of like doing geospatial on Parquet sounds like a very, very good idea. Parquet is a very, very well-known format. It's the foundation for Iceberg and other open table formats. And it made a lot of sense to kind of like make geospatial part of that ecosystem. And since then, the adoption has been amazing. I mean, we have now GeoParquet support in many, many products. And we have seen actually how useful it is for sharing data, distributing data, and and reaching all these interoperability objectives. So I think it's been incredibly successful as a format. But this year, and this is incredible news, we've gone even farther. So in just a couple months ago, finally, geospatial data became a primary data type on the iceberg and parquet formats. And what this means is that we're no longer an extension. It's not that, we have our well-known binary, like as a thing that you put on top of your database, but the database doesn't understand it. No, we are now a native data type. Similar to what you have strings and booleans and numbers, now you have like geometry and geography data. And that is huge. That is huge because it's finally making us, like geo, not a special thing. Now geo is at the center with the rest of the data. And it's also huge because it's going to push, and it's pushing very hard geospatial adoption across the bigger analytics landscape. And in fact, that's one of the most exciting things. As you see, the major products. Right now, DuckDB is it's an open source you probably are very familiar with, has already support for Iceberg with geospatial data on it. But all the major data players that I was describing that are here today are working on it. We know it for a fact. In the next few weeks, in fact, there's going to be some very big announcements by all of them on these topics. And that's an incredible push, right? We no longer, again, the fact that these engines are going to add geospatial support, like natively in Iceberg, means that they're going to have to compete on performance, that they're going to have to treat geo like they treat everything else. So for me, this is year is a year that we will remember, because it will see the increase on capabilities and performance and value that we can get, by converging with the whole analytics industry. Now, it's also an important year to consider your geospatial data management architecture, if you want to say. So some of you probably have chosen, to store your data on safe files. Hopefully not many anymore, but in different kind of databases, Oracle, BigQuery. There's many different kind of systems that you have in. In the next months or next years, you're going to have to start thinking about how potentially you can transform that to an open table format strategy, where you manage your geospatial data in Iceberg, so you can benefit of leveraging all this engine and all these new technologies from it, right? So probably not as now, because the support is just very, it's just getting started. But over the next few months, consider that as part of your strategy, how you're going to be benefiting from this. It is going to be a very big step in there. Now, geospatial data is not only vector. So geospatial data is complex, it's large, as we all know. And we've already talked about vector data, so I put kind of like a check, right? So we have already vector data open up in this open table formats I was describing. But what about other formats like raster data, trajectory data, or LiDAR, and so on? I want to make the case that we have to go towards adding all these data sets in the same path. So let's start with raster. So raster, move to the next one. Oh, yeah, better. So raster is obviously one of the most important types of geospatial data that we have in our industry. It helps from remote sensing, but it also helps in anything around modeling. And the idea of being able to work with raster data together with vector data seamlessly using SQL in the same platforms without having to use specialized tools, to access that information is very, very appealing. That's why we've actually at CARTO, we've been working for now a number of years on a format called raster with parquet. So, that's our naming in there. So with the goal really of opening up again the same way that we did with GeoParquet, doing now with raster data, right? So it is an NDV storage format that is going in the same direction. And we've seen already quite a little bit of traction. It's open for feedback. If you're looking at, this is something we'd love to hear from you. And we're already internally using it inside CARTO. It is our in-database storage format, and we just actually added support so that you can visualize it on Builder. You have analytics on SQL, so you can operate with rasters like if it was just one more regular table. So very excited about that. That I think is well on the process to follow vector. Now, what about trajectory data? So trajectory data, you can define it as objects, things moving over space, right? And this is a very important data set because it helps us to understand mobility, it helps us to understand, to do urban planning, all sorts of things, right? So moving things over space, over time, is very often called mobility data or trajectory data. I want to call so a little bit, like the typical kind architecture that you get on this kind of type of data. So think about, like any fleet management or any kind company that is collecting from cars positions over time, right? So they got all these sources of data of essentially kind points with timestamps and other attributes like speed or whatever other attributes that they're collecting over time, right? So the most common way what you get is, like you ingest the data from all these sources into your data warehouse, right? And then you have to go through a process of cleaning the data. Normally it's very messy, like the GPS tends to be very messy. You have to simplify it, and you have to match it. You have to align, like those coordinates to actually a road segments. And then you get what we can call cleanup trajectories, right? So these trajectories are more like, if you can think of your ingestion where you have like one row, one point. In a trajectory kind data model, you will have like one row, one trajectory, many points, and with attributes like that. And when you get it in this cleanup format, you can do and perform analytics and visualization. Analytics like detecting stops, like derive metrics and reach it with other attributes. Or if you want to visualize it, you're gonna want to visualize aggregated versions, like a density of like the places, or how things are moving, etc. So this is and ideally this will whole thing be in a streaming way. So you get like data continuously, it's being processed, it's being ingested, it's being analyzed, and and you are creating all this analysis in space. So we're seeing that a lot being done by a lot of our customers in the industry. So we hear from them like a few challenges. So the first one is on the visualization side. These data sets tend to become really, really large. You can imagine you have like thousands or hundreds of thousands or millions of cars or devices moving, and they are all streaming data every 10 seconds. You very quickly end up with tremendous data sets. So how to visualize this type of data for debugging and exploration tend to be really hard. So what we've actually been working at CARTO is providing ways to get like this data in a tile-based way. So a way to explore data sets and these trajectories, maintaining the shape of them, but handling like very, very large data sets. And we're building it on top of DeckGL, our own entire libraries around it, providing you with rich cartography, and it's coming to builders. So we're very excited about this, and we think like this is something you'll enjoy. I just want to give you a quick example of like how it works technically. So this is the new engine behind it, and you can see like every time we load like a tile, what we're doing is just retrieving parts of the trajectory and simplifying it for the purpose of the visualization where I'm looking at. So and we are retrieving the tile data. This is on the red thing, and what we call the meta tile data around it to complete the trajectories. So there's a lot of technology to essentially allow you to explore a data set, a rich data set like, yep, all right, here. A rich data set like this, that's it, and in an effective way. So very excited about that. Now, the second part is around analytics. Once you got all this data, how do you actually analyze data with it? And for that, we've introducing a new workflows extension in CARTO to work with trajectory data. And that's like a set of capabilities that allows you to generate and manage your trajectories, but also analysis like I was describing, like a stop detection, intersecting trajectories, like enrichments, all those components that allows you, once you have your data clean, to actually derive value from them. All of that built on SQL, as always, and available in our workflows environment. So the idea is really, again, to democratize, to make accessible this type of analytics in a much more visual way, all, again, powered by the underlying data warehouse engine. Now, we're doing this, again, moving through as a community initiatives. We're part of a European project called Emeralds, where we are like advancing mobility analytics and mobility data. And we're also doing it in the context of the Open Geospatial Consortium to be standards for solving this type of use cases. There's a talk later by Anita on moving pandas. So if you're interested in this type of data, this is a very, very exciting. I think it's the first time that we've talked at the Spatial Data Science Conference around this type of geospatial data. But there's a lot of advancements in this space. So very excited about that type of data. And the last one where I have less to tell you is around LiDAR and point clouds, right? So this is also a very, very rich and very, very large type of geospatial data where collected normally automatically, that is still very much living on its own formats and not connecting with the rest of the world. So there's a few initiatives here, but this is still just getting started. So if you're interested in LiDAR and point clouds, it's a lot to talk to you because we're just kind of getting started to look at it. But I would say it's probably the one that is more behind on the rest of the types of geospatial data. All right, so that's on the format side. You see, like we talk a lot about how we can convert all these types of geospatial data. And from my point of view, one of the most important things beyond the convergence with the analytics space is that if we don't do it, we will not be able to benefit from AI. Most of AI capabilities are being built on this analytics platform, and this analytics platform works with these formats. So we better adapt our formats and our tools, our technology to work in that way so that we can take advantage from it, right? Not having to reinvent it all. And one of the most exciting things around AI that I find is this concept of geospatial reasoning, or making geospatial more widely accessible. So let me elaborate a little bit on that. I think here we all love maps. That's very, very clear. That's probably why many of us, got in this industry. It's just like how fascinating it is to look at maps, but also to create them. I still find myself, like very often making maps myself and spending, like hours, just like looking at the details and discovering my own stories inside them. They're like very effective, kind of like a storytelling type of, like tools. And again, like what probably many of us are in here. But there's actually a crude reality out there, is that maps are sometimes not as accessible as we will all want to believe they are. We all love here maps again, as we say, but on our own metrics, the average time spent and looking at some of our dashboards and maps and that we make is less than 2 minutes, or around 90 seconds. So most people come to a map, they pan a little bit, they maybe bounce, they maybe look for the house, they too much, and then they bounce, they go somewhere else. So maps are not necessarily that accessible as we might want to think. I like to say that maps shouldn't be a puzzle. And this is something, where AI is actually going to help a lot, because or it's going to even accelerate it more. In this era of ChatGPT and AI, I mean, like we are all becoming very, very now used to just ask the question, right? Ask the question and get the answer. So if, to get the answer, you have to explore on your own, click on 10 filters, compare different layers and so on. Well, that's not going to make us competitive as an industry. People just really want to talk to the maps. So that's why at CARTO, we introduced last year, we started working on this concept of CARTO AI Agents, on this idea of talking to the map. So the idea that you could just have a map and you have an AI that will answer and give you information around what you see in the map and can control the map as a way to improve the usability of that map with no coding required and so on. So that's how we started. And the impact is pretty amazing. When you look at, when you add a conversational experience in a map, the number of questions that people start making to the map and the amount of engagement increases dramatically. So if you're looking at any designing of a new interface or like a new experience to get insights on a map, you gotta consider this, because the results of providing these type of conversational experiences versus kind of like do it on your own, kind of like explore on your own, are pretty dramatic. So I think this is very clear. We're likely going in this direction where like AI will be in some ways the new interface to interact with our data. And again, we've been working over the last year with some large organizations. It's very interesting because in this new era of AI, it's very, very important to understand in particular what type of questions people want to get answered. It's very easy to come and put like an AI and it will actually answer nothing. So it's very, very important to work in actual specific use cases, as you will see. And it's very, very important to work with the industry to really grasp like what is the value that the maps are making and what is the insights that people want to get from them. So that's why we're working a lot with companies on this space. Now, a little bit of also other introductions here. In 2025, we've seen the rise of enterprise agent platforms. You know some of them. If you go to ChatGPT, there's a ChatGPT Enterprise that can connect to your enterprise data and you can talk to them. You've seen Claude for enterprise. But then the major cloud vendors like Google has announced Agent Space, Salesforce Agentforce, Copilot, Microsoft, is this whole idea that organizations will have their own kind of like enterprise, kind of like chat system where users will be able to interact and get most of their day-to-day work done, right? So this has really come up in 2025, very, very clear. And this is how, in a way, I like to explain it. You can think of it as the agentification of the enterprise, of the organization. Think about like this is a made-up company to reach out-of-home advertisement type of company who has like many departments. And each of these departments have a number of kind of like use cases, things, like processes that they solve, right? That they offer to the rest of the organization. So if you are an HR agent, you've got, like, so if you're in HR, you handle kind of like requesting holidays and managing time off, etc., right? Financial agent, you get the idea. Well, it is easy to believe that, like if, oh, no, not before I get there. Oh, sorry. Before I get there. It's easy to believe that, like, after this conference, probably if you have to submit your expenses, you probably prefer to kind of like submit it to an AI than have to handle it yourself, taking the pictures, kind of like, inputting forms and so on. So that is very, very clear that we're going in that direction. So now, how these kind of like enterprise AI platforms will work. So the idea is that these different departments are exposing their capabilities as agents. So when I make a question, like for example, I want to make a new campaign for a customer in San Francisco, the enterprise agent has a number of sub-agents registered for each of the departments. And one of them, in this case, the geospatial agent, was like, yep, that looks like a geospatial task. And I actually think I can do that, right? So that agent has registered its information on the use case it can solve. And it says, yep, and I have an actual agent for that. I have a campaign designer agent that has been created specifically to answer this question. So I can handle it. Great. Now, this agent also has access to a set of tools, like has access to database, has access to data, it has access to workflows, like how actually you design like revenue prediction or like specific business processes. It also has access to third-party services, can send emails, whatever the process is to make that happen. So you can see how starting from this enterprise agent, there is already an orchestration of agents from department to department, right? But it also gets, like interesting, because it breaks a lot of the silos. So think about, like a question like, can you help me visit my top customers in London before I go on holidays? In order to do that, the enterprise agent is going to look like, okay, well, I need to talk to the HR agent to get, when he's taking holidays. I talk to the sales agent to figure out, where customers are. And I might talk to my geospatial agent who has a tool to organize sales trips for a person. So you see now how this orchestration of the different agents will make geospatial much more accessible because also it's putting in context of other agents at the same time. That's going to be quite powerful in a way. Now, something very, very important here, and I think for me that was something very easy misunderstood. Agents don't think. Agents follow instructions. And what I mean with that is like in this enterprise kind of like agentic systems, we're looking at the AI to look at can I answer this question? And instead of like trying to figure out on its own, like being ChatGPT tell me a story, it's looking like is there any agents and tools that can help me solve that? Because if there is not, I prefer to say sorry, no, I don't have actually the capabilities to answer that question, right? So in a way, you have to think that like this is AI being intelligent and choosing the tools that have been given to them, not at making it up the analysis on their own, right? This is what is actually been very different in this year. And this is why in 2025, we've seen the stack being ready. And there was a lot of risk before, like if you put, like an AI, to tell you, like, tell me what is going to be the revenue in this location, it will either made it up, or it will actually be nonsense, or it will actually not be right. What we're looking in 2025 is this orchestration protocols have emerged. Now it's possible to register these business processes, these tools and agents that talk to agents. All that infrastructure is already there. And there's a new set of agentic models like Gemini 2.5, Claude 3.7 that are very good at, like choosing these different tools, and also saying like, I'm not going to continue if I don't know how to answer this question, because I'm just actually kind of like operating with what I have, right? So that's why this year, this is really ready. And one great example of that was given by Google at the last Google Next. In this demo, what they made is an application to provide, like the user with the capability to understand the impact, in this case, of a hurricane. So just a user asking like, okay, there is, like a hurricane coming, like, what is the kind of infrastructure is going to be affected? Like it's actually looking at, adding layers dynamically. It's kind of like using different tools to work in this specific use case. So if you're like an insurance company and you want to have like a continuous monitoring of your exposure of risk to a specific kind of case like this provides a very intuitive, experience for the user to like just ask questions like, okay, what are the properties that are going to be more affected? What is the total value that is under risk? Which areas? So that's the experience they are providing here. You should check out the video later. It's truly magic. When these things work, the idea that you can just ask questions and the agent is manipulating the map and connecting the tools that a professional has designed for them, it's pretty unbelievable. So this is what we call geospatial reasoning. The concept of like you provide a geospatial or GIS system, a set of information layers and tools so that someone can, with natural language, start making questions and get to resonate with that system to get its own answers, right? And this is the breakthrough in a way to really, from my point of view, democratize access to our industry. Because if we make our data and our analysis accessible this way, the number of people that can actually benefit from it just really explodes. So I think that's really, really exciting, this whole concept of geospatial reasoning. So at CARTO, what we're doing is making agents a first-class object. And so in CARTO we have like, you can make maps, you can make workflows, you can get data from data observatory, or you can make applications. Now, you're also going to be able now to make AI agents to essentially do the things that we were describing before. And the way that you make them is by using different parts of the platform. So first one, to make the agent, it's really, think of it as prompt engineering, like just writing what these agents will be doing, what use case will be doing it. So you do that in Builder. You tell what is the intention of the agent, what use cases. And for those use cases, which tools should it use? What data layers it should use to resonate? What it should do in some cases, what it shouldn't do in other cases, right? So you design it in there, and you design it with natural language and choosing tools. The second part is that these agents need to have access to tooling. If you're gonna have a site selection use case agent, you're gonna want to potentially have something like revenue prediction, or calculate risk in this case we have it here. You don't want the agent coming up with its own revenue prediction model. You want to create your own revenue prediction model and tell the agent, whenever you're asked something like this, go and use my analysis. And this is the big change here, one more time. I mean, it is not the agent doing GIS, it's the agent detecting intention and calling what it has been designed to do for you, right? So you design the agent in Builder, you create the tooling in workflows, and then you consume that agent in what we call in different locations or different. That's what we call a multi-channel integration. You can imagine that like in CARTO itself, if you are working with an agent, we can have very rich interactions. We can zoom in, we can activate a layer, we can do many things. We can highlight areas of the map. We can do a lot of very rich interactions between the agent and the user. But when you're doing that on ChatGPT, if I integrate this in ChatGPT, now you're not going to be able to embed a full flavor map inside ChatGPT. You might just get an image and a link to a map, right? Or if you build it into your application, you're likely going to have to connect it to your own logic within that application. So you see where this is going, essentially is you're going to have to design agents that respond differently depending on where they're going to be used. This is what we call multi-channel integration, right? And that's all built in and prepared for that and defined on the protocols. It's going to be very, very important also to think how the agents are going to be used. Now, also on the process of working on this whole area in CARTO, when talking to many of you, you expressed very clearly the need to treat this in a very enterprise rigorous way. it's very clear that when you're working with enterprise data, you can work with very sensitive data, and AI and LLMs can have the potential that to exfiltrate data and do certain things that you're not comfortable with. So what we're working is with the possibility so that you define your own models, your own providers, and very often even companies have their own AI proxies that essentially allows you to proxy all the requests through them, and so that they can check for data exfiltration, quotas, and many different things like that. But most important, because all of this is running on the infrastructure of the data warehouse, data never leaves your infrastructure. It's all secure within your enterprise environment. And we've heard from you that was very, very important to enable these experiences. Now, going back to what I've been repeating several times, agents are as smart as the users that are creating them. And that's what they should be. You don't want the agents to make up things. You want the agents to follow whatever you've designed them to do. So it's really our responsibility, and this is the path forward for our industry and for us as professionals. So it is, we have to be the owners of those agents, defining, what they can do and how they should do it. It's not about delegating to them to do our work. It's about telling them how we want our work to be done, right? So very, very important concept. And I think, in a way, Kala tells us, a big picture of redefining what we do as an industry, what we do as professionals, right? What we do, our departments do. From building maps, where, we design layers and we update them, to a new world where what we're doing is building spatial agents. So figuring out, how to design the reasoning flows, monitor them, and adapt them. So if a user asks you for, hey, I want to do a revenue prediction on this location, say, sorry, I cannot answer, I don't have a model for that. Well, maybe you might want to add that to your agent, right? So you have to keep refining it so it answers more and better the questions. So if I summarize it, you can think of it from what maps should I make, to start thinking about what questions should my agents be able to answer and enable them to do so. So that's, I think, where we are all going. So I think with that, hope just give you a brief introduction, a brief picture of where this whole thing is going. It's a very crucial moment for our industry, but I think it's also very clear why we are more needed now than ever. The idea that AI is going to replace us all in this industry is just totally unrealistic, and more important, it's we better be at the seat front, when it comes in this revolution. So yeah, looking forward to talking more about it. Thank you very much.